Hi, I'm Trevor Kruger. I'm with AdNet Services, and today we're going to talk about Cisco Unified Communications on their Unified Computing System. So traditionally, in a traditional network, you had all of your communications platforms running on 3 disparate networks. So your data network consisted of a switch, a data switch, network switch, that connected to a router, which then connected to the outside world, whether that's your WAN or your internet and so forth. Plugging into your switch in the traditional network were PCs for the average user, and also servers, whether it's email, other applications, that sort of thing. Then you had your video. This is supposed to be a TV. Your video network would be a completely separate network, completely separate cabling. And then you had a traditional PBX, which would power your telephones and your voice network, all separate. The PBX consisted of about 4 different things. You had your trump cards, which got you to the outside world, which is called the PSTN, or Public Switch Telephone Network. This is your AT&Ts, your Ma Bells, Sprint, that sort of thing. That's how you connected to other businesses and whatnot. The second piece to the PBX was your station cards. And your station cards are what connected to the actual phones within the network, or within the business. And then the other piece was your CPU and voicemail. CPU is what the call control sets up, breaks down your call. It is what actually happens when you press 1 on your phone or 0 on your phone, and it gives you the dial tone. So what Cisco did was they came up with a way to collapse all 3 of these networks into one network, because essentially what they said was why can't we take voice or video and just turn them into data applications that are residing on your network? So that's exactly what they did. So what they did was, instead of having a station card where your phone's plugged into it completely separate, they said, why don't we just plug our phones into the network switch? And that's exactly what Unified Communications has done. So now you no longer need a phone or a station card residing inside the PBX. Now the switch is going to act like that station card. It's going to power this phone without having any sort of power brick, and it's going to be attached to the same data cables that your PCs and your servers are attached to. Now, the next thing they said was how can we connect this phone, once it's an application on the network, once voice is an application on the network, how can we connect to the outside world? So they said we need to turn something into a trump card. So what happened was, they said, well, we can put a trump card in this router. So now the router is now acting as a trump card on your network. And there are PSTN cards that you can stick in this router that will allow you to terminate PRIs, SIP trunks, whatever mode of communication this is, that would allow you to connect to the outside world. So all we have left now are CPUs and voicemail. Well, that's the easy part. If it's an application running on your network, like voice is these days, every other application is housed that's on your network, whether it's email, whether it's file server, whatever it is, it's housed on a server. So you've already got that technology that's done. So what we did or what Cisco did was take the CPU and turned it into an application on a server that they call Unified Communications Manager, or UCM. And the voicemail is the same thing. another application running on a network, residing on a server, and they call it Unity Connection. And for video, they did the same thing. Now these video endpoints, all they are data endpoints that are attached to the network switch. So, as you can see, we've got all of the voice applications, or all of the voice components, and all of the video components now residing on the same data network that they already had. You already had a switch, you already had a router, and now instead of just using those two to connect to your WAN or your internet, we're now using them to connect to the outside world via voice communications or video communications. Now you're asking me, well, how do you know, a lot of times there are issues that are on the network that maybe sometimes servers get viruses and they clog up the network, and you know, in most businesses, phone equals money or voice equals money. Uptime is king. You have to be up 100% of the time on the phone so that our contact centers can do work, so that our customer support can support our customers. So how do we do that if they're all physically riding on the same network? Well, that's simple. There are two technologies that are out there called VLANing, which is virtual LAN, and quality of service. So inherent in the iOS on these switches and routers are the ability to logically separate this one single network into many multiples of network, so that you can put your voice traffic, logically put your voice traffic and your video traffic, even though it's still connected into the same switch, on two separate networks. So that if your email, somehow somebody downloads a virus that they get via email and it goes to every PC out there, logically we can crunch that to where it will only affect the data network VLAN. The voice VLAN will not be affected. And at the router level and at the switch, we can prioritize traffic so that if the data VLAN's getting hammered by a denial of service virus, then we can say, you know what, you sure are starting to eat up a whole lot of our bandwidth, but because voice is the #1 prioritized data traffic on our network, you're starting to take over some of its bandwidth, we can crunch yours down to where we can have nothing but the voice traffic going out and being priority one. So that's how you kind of separate everything into multiple VLANs and utilize QoS to where we can guarantee 100% uptime on the phone system. All right, to take this a step forward, what I showed you here was one site. In the old traditional PBX environment, essentially to all of your, if you're a company that's got a remote locations spread out across the US or state or whatever, you basically have to have the exact same setup with a PBX that we had here at every other site that you have throughout the country. In Cisco's UC story, what they do is it's what they call a centralized processing model, which basically means since your call processing is on this server, just like any other applications you would have on your network, we're going to allow this server to power up every other site that we have, be the call processing unit at every other site that we have. So rather than sticking another PBX and another voicemail module at every location, all we're going to have is a router, a switch, and phones, which you would have to have out there anyways. In your traditional environment, you're going to have a PBX up here that's going to be connecting to the PSTN, and you're going to have a router and a switch anyways with computers connecting back to your central servers, or you're going to have servers out here, however your network's set up. So in the Cisco model, in the centralized processing model, this router is going to act as the connection point back to the call manager server. So you're asking, what happens if this link goes down? Again, this router is going to have what they call SRST, or Survivable Remote Site Telephony technology embedded in it, which essentially turns this router into the call processing model or unit in the event of a WAN failure. So this router, the same as this one, is going to be plugged into the PSTN, and in the event of a failure, instead of connecting back to Call Manager, it's going to power up this whole site with Call Manager functionality that's then going to reroute traffic instead of going back across the WAN and out the PSTN there, to just go straight out the PSTN at the site using local lines that are plugged into the router. So this could be in Charlotte, this could be in Charleston, and to the end user, you would never know. This goes down to the end user. You're now running out these lines rather than going out back across the WAN, and you're going to have phone service up 100%, or 99.99. That's it. Okay, so now that we've got your voice, your video, and your data all running on one network throughout all of your locations, now how do we take that a step further to the actual servers that the applications are running on? In Cisco, in this drawing here, we've basically shown that we've got Call Manager and voicemail running on two separate servers. In reality, there's lots of different applications that are offered in the unified communication system. Everything from mobility, single number reach, presence, contact center, and all of that in Cisco's traditional voice platform requires its own separate server. So what Unified Computing Systems has done is allowed you to take all of these servers away and consolidate them onto one large server. Blade server, or it could be a rack server. But in the UCS environment, it's a blade server. So how then do you collapse 6 servers, and if you want redundancy, multiply that times 2, 12 servers down into 1 or 2 physical servers? Well, the answer is through virtualization. So what Unified Computing Systems and Unified Communications Manager 8.5 has allowed is the ability to run all of your voice applications virtually on one box. So now we've got Call Manager, Unity Connection, Presence, Mobility, Contact Center, all running as virtual machines using VMware technology on this one Unified Computing System platform. And then we can take that even a step further, and we can deploy a second one of these. It can be a second one coming out of this switch over here. It can be a second one out in one of your remote sites for disaster recovery purposes. If this location goes down, you want to have this up and running over here so the rest of your company can be up and going at all times, or it could be at your co-location facility. So Unified Computing has, to recap, allowed the ability to take advantage of virtual VMware applications to utilize your voice platform on one server or 2 servers and consolidate all the space that was taken up in your data center and take advantage of that technology.